Before we go any further, we have to stop, take a couple of minutes, and have this conversation. Here we go, back to the lecture. There it is. The chain rule really helps to explain Leibniz notation. The notation that typically looks something like dy over dx. So I said before, this is not a fraction, dy over dx. It simply means the derivative of y with respect to x. Well, how did this notation come about? Why did Leibniz choose this notation? Leibniz is known for being really careful about the notation he would create for new mathematical ideas. He would spend days or weeks coming up with a notation that he felt was intuitive, simple, compact, small enough, easy enough. And in the end, his notation for derivatives, it worked. We still use it today. Things like dy over dx. Let's look at it through the lens of the example y equals the quantity x cubed plus 1 to the 10th. So the way Leibniz thought about the chain rule here, he defined a new variable for the inside function. So let's call it u. Let's say u equals x to the third plus 1. So we're thinking, okay, y equals, so it's all right, we're kind of simplifying things. He would kind of break it apart as two functions. So if u equals x to the cube plus 1, he'd say, okay, y equals u to the 10th. It's like being substituted. And then he would note, and of course, u equals x to the cube plus 1. So the two of those together make the original function. And here we can really clearly see the outside function, u to the 10th, and the inside function, x cubed plus 1. Okay, so then he would take derivatives of both of these things separately using his notation. So for y equals u to the 10th, he'd say, well, dy over du, the derivative of y with respect to u, is 10u to the 9th, just a normal derivative there, power rule. For u equals x to the third plus 1, du over dx, the derivative of u with respect to x, equals 3x squared. So both of these simply are polynomials at this point. Then you'd say, okay, but if you want to know the derivative of y with respect to x, multiply these two together. And those are like the two links in the chain, and we bring them together to start to get our final answer. Dy over dx is 10u to the 9th times 3x squared. But of course, we don't want the u in our final answer, so we would substitute back in what u was equal with. X to the third plus 1 gets put in there, but there you have it. First link in the chain, second link in the chain, multiply them, there you go. Okay, so how does this explain his notation? Like what, we haven't even seen that yet. Look at just this piece right there. This is dy over du. This is du over dx. Okay, so we said these are not fractions, but they sure do behave like fractions if we use this notation, right? Because if we thought dy over du times d over dx, wouldn't the du's like cancel out? And we just be left with dy over dx. And so he'd like that aspect of it, that they behave, even though they're not fractions, they behave like fractions, which makes it intuitive and easy to use. And it really gets highlighted well here when we see the chain rule. All right, you guys, that's it. Check out the homework.